Okay, so 5.5 combinations, permutations. Permutations, the order matters. Combinations, the order does not matter. So we are lining up the students in rows. Now, if you're standing in that row and you're in second grade, it matters if you're in the front of the line or the back of the line, okay? So if we're doing it as a permutation problem, the first number is how many people do you have? And the second number is how many people are you using? So, my first number is the number of people you have. The second number is the number of people that you're using. So how many people do we have? 15. And how many people are we putting in line? 15. So we're doing a permutation of 15 people using all 15 of them. So when we go to our calculator, we're going to put the 15 in first. Then we're going to do math over to probability and down to NPR. So 15 NPR 15. 15 NPR 15. Now, y'all pay attention to what this means. What does that mean? It's an exponent. This is the same thing as 1.307 blah, 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 blah times 10 to the 12th. Which means if we take our decimal and move it 12 times, that's how big the number is going to be. So if I take my decimal and I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my answer is 1307674368000 because I ran out of numbers. That is how many ways that we can line up those 15 people 15 different ways in line. We're not going to try that. We're not going to say, hey, let's do an activity today. Let's see how many different ways we can put y'all in line. That ain't going to happen. Now, the other way that you could do this problem is you could say, for those that visually want to see it, you could say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If these are my 15 little babies, how many people do I have to choose from for the first spot in line?
15.
15. And once I put Sally there, how many choices do I have for the next person?
14.
And the next person?
13.
Did it just get brighter?
It was
Next door. So, if I think of it visually, this would be the same thing. So what would I type into my calculator? What is an easier way of typing that into my calculator?
The exclamation.
15 with the exclamation point, that's 15 factorial. So just to show you I'm going to get the same answer, I'm going to do 15, hit the math button, go over to probability, and the factorial button is right below the NPR, NCR. And it's going to give me the same exact answer. So for that one, you could do it either way. We good? All right, then I have it written out prettier down there. Pull that up so I can have a little bit of room in case I need it down below. A certain digital music player randomly selects each of 10 songs. Once the song is played, it is not repeated until all the songs have been played. And how many different ways can the player play the 10 songs? What do you think? Does order matter? Does it matter? I mean, so do you think this is going to be an NPR, NCR, or a blank problem?
NCR. Because it's not repeated.
Now, NCR and NPR are only gonna be if the order matters or not.
Oh, so still an NPR.
And if I do blanks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, how many choices do I have for that first song? 10. How many choices do I have for the second song? How many?
9.
It is not repeated, so you have 9. How many do I have for the next song?
8.
So that will be 10 factorial. Now, if I did it, this is like lining up people. You're lining up songs. So you're going to play, whatever song first, and then the songs are coming out in an order. The order to you doesn't matter, but they're coming out in an order. So if it's, give me 3 songs. Let's Get It On, and
I Will Always Love You.
I'll Always Love You, and
All on the watch hour.
there you go. If you play them in those order and then you play I'll Always Love You first, then those are 2 different things. You with me?
I appreciate it.
So the order is going to be different each time because you're lining up the songs. It's like lining up people in class. So this is going to be an NPR because the lineup of the songs is different each time. Does that make sense? The lineup is different. If I switch them around, the lineup is going to be different. So how many songs do I have to choose from? And how many songs am I picking? I'm still going to get that same answer. So if I go to my calculator, I'm either going to do 10 factorial, 10 factorial, or I'm going to do 10 NPR 10. Because if I do I Will Always Love You, and then the greatest of all time, and then Let's Get It On, and then I do Let's Get It On, and then the greatest of all time, and then I'll Always Love You, that's 2 different song plays. So the order of the song plays matter because they give me a different answer. All right. Oh, let me move these up so we can't look. I love these kind of problems. Social Security number is used to identify each resident of the United States uniquely. The Social Security number is the form of rank, dash, rank, where each rank is a digit from 0 to 9. How many Social Security numbers can be formed? Okay, so for this one, I am seeing blanks. Did you get done? Okay. All right, so for that first blank, how many choices do I have for a number?
10.
Because I can choose a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. So 0 to 9 is 10 numbers. Y'all with me? How many digits do I have to choose for the second one?
10.
10. How many for this one?
10.
So it's going to be 10 to the what power? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the 9th power. So y'all, we are going to be screwed if I do 10 to the 9th power. So once we get past one, 2, 3, 4, 5, 6. Once we get past giving out this many Social Security cards, then we're going to have to make it longer. Or we're going to have to do something. We're going to have to add letters in it or something. Now, what if I said you cannot repeat the numbers? Come in, Miss Bauer. Would you like to give a little speech to our class?
I would love to give a little speech to your class.
Come on up here.
I will come up to the front so they don't have to turn around.
Yes. This is Miss Joy Bauer. She is one of our Rush tutors, coaches. She's
Yes.
a coach.
But I help, it's a tutoring kind of thing. But myself and Miss Munn are for one side of the Rush program, and I don't know his last name.
Karuba Valfason.
I think that's right. And Mr. Maxwell, you guys might have seen him right down the road here, or on the hall, not the road. But we are math coaches for both sides of the Rush program. But I only have applications, well, it might be for both sides. But we help people with math in this building, but it's not just for math, it's also for biology or for English. So if you're having trouble in a biology class, there's a great biology coach for that. There's also a great English coach that could help you if you having trouble writing any papers, or if you just wanted to let somebody read your paper and just make sure you got everything in the right spots. Not just for English, maybe a psychology paper or another class. They would read it for you and check on it for you. There's also a book loan program, so if you needed a book and you couldn't afford it, you could be loaned a book. You could also be loaned a calculator. When I was in your spot many years ago, I did not have much money, and so if somebody wanted to loan me a calculator, I would have taken them up on it in a heartbeat. So but it's a great program that is here to help you. So if the hub tutors aren't available, or they're just really busy over there, they should be available. But if they're really busy over there and you needed some one-on-one help, or we sat down and we looked at the problems with you and made sure you were on the right track with them. We even have somebody texting me right now, problem, trying to get some help because they're at work and they can't make it here. We have that ability too to help you that way. So if you would like an application, I know you came to see me just a minute ago to get an application.
She got one on Friday.
I have a couple of them here, hopefully enough. So,
And can you leave me one so that I will have one as well?
try. If not, I'm going to go and make more copies.
Okay.
So,
Anybody else
I'll leave you
interested?
one. Anybody
got
else?
two more over there?
Okay. So,
And I'll
they
have
get
one.
returned to the 5000 building to room 5313. That's up in the top right-hand corner. Tells you where to return it. So they would love to have you bring that application over, and it's a real quick interview. They just ask you a couple questions, and then we have not seen anyone turned down. So everybody
And it's
that we
totally
know-
free.
Yeah, totally free. You do not pay anything, and you get lots of good services. So. There's a field trip at some point that they go on. There's an awards banquet at the end. We pick people out that have worked really hard and get some awards at the end. So it's a really neat program if you're interested. So thank you for
They
letting me
have
come
a
in.
really, what was y'all's pass rate, increase rate, whatever last semester?
We had, I think it was in the like 96th percentile. Everybody,
math.
they came to see us. So the people who were on our program and that came to see us. There was one person who came less, and they didn't quite make it. Everybody who came and worked with us passed. And some people made better grades than they were intending to make, so, or expecting to make. So we really love helping with math. We'd love to see you guys.
Thank you.
Thank you for letting me
You
come
were
in.
just on video. Right,
Oh,
too.
great, okay.
Sorry.
Thank you.
So this is if every number can be repeated. Now, what if we said we're making new Social Security cards, or we're making ID cards or whatever, and the numbers cannot be repeated? This would be 10, then what would this be? 9, 8, 7, 6, 5, 4, 3. So if we cannot repeat the numbers, it would be 10 factorial. You with me? So whether they can be repeated. So we're actually getting more Social Security numbers by them repeating. Let me throw in another one. I love doing this one. Let me go down to the bottom, and I'm just going to make a new one. In South Carolina, our license tax, is it 3 numbers and 3 letters, or 3 letters and 3 numbers?
3 letters and 3 numbers.
It's a letter, and then a number. How many different license tags can we give out in South Carolina before we run out? Can numbers and letters repeat on license tags? Now, I don't know if you know this or not, but they will not let us have an X right here. Do we know why? What's an X for? Dealer tags. Yeah, that X is for dealer tags. So they won't let that X go to general public. So, if there is no X right there, but all the rest is fair game, how many choices do I have for that first letter? 25, because there's 26 letters, but I can't use an X. Okay? How many choices do I have for this one? 26, because I can use every letter in the book. How many letters do I have here? 26. How many numbers do I have? 0 through 9, which is 10 numbers. How many numbers here? 10, and how many numbers here? 10. So if I go to my calculator, it is going to be 25 times 26 times 26 times 10 times 10 times 10. So this is how many license tags we can make in South Carolina before we run out of license tags and have to repeat. Now, if you look at North Carolina license tags, have you ever noticed North Carolina license tags? They have 4 letters and 3 numbers. So by adding an additional letter, that's going to be multiplied by 26. So they're going to have 26 times as much as we do by throwing in an extra letter, because their state's is bigger than ours. Now, when you go to California, you're like, oh my gosh, how's California doing this? Well, South Carolina, all of South Carolina uses the same plate, but if you go to California or Texas, they have by county. They'll say Orange County or Dallas or whatever. So they have that many per county. We have that many for our entire state because we don't have counties on them. So like my daughter and I went to the beach over the weekend, and I'm very OCD and just pay attention to this stuff because it's very mathematical to me. And so you can look at tags, and sometimes the tags will say, in Mississippi they have Jackson. Jackson County. And so I'm thinking, oh, they have that many in that one county where we have that many in the entire state. All right, let's look at, just love doing these. Let's look at, there's our Social Security. Let me pull this down so I don't show anything that I don't want to show. There's my Social Security numbers, and then there's if it's not repeated. Let's see. What is the probability of correctly guessing the Social Security number of the President of the United States? What does probability mean? What makes me happy over total, right? So anytime I see the word probability, probability means what makes me happy over total. And total is the same thing as sample space. Sample, S-P-A-C-E. Sample space is the whole thing, like the population, the whole thing. So your sample space is your total. So what is our total number of Social Security numbers? That 10 to the 9th. Right? And how many Social Security numbers are going to make me happy? 1. So the only Social Security number that's going to make me happy is the President's. And the total number of Social Security numbers are 10 to the 9th, which is what we calculated right there. So the probability of me guessing, and if I come over here and I do 1 divided by the previous answer. Now, this time, our exponent says -8, which means we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So, the chances of me guessing the President is 1, 2, 4, 5, 6, 7. Am I going to guess his Social Security number? No. That is pretty top secret. It's like moving so slow. Okay, there's that. All right, number 42. How many usernames are possible in problem 41 if the last character must be a digit? So you had to see number 41 before you could do number 42. So here's number 41. Suppose that a local area network requires 8 letters for usernames. Lower and upper character letters are considered the same. So it doesn't matter if you put a capital P or a lowercase p. It's the same thing. So we have 8 letters, but they're saying now the last one must be a digit. So we have 1, 2, 3, 4, 5, 6, 7, 8. And it's a letter, but now a number. So what's the choice that the first one's a letter? 26. The next one?
26.
The next one?
26. The number would be 10.
And we would multiply those together. Now, y'all, what if we said it was lowercase and uppercase? Lowercase a is 1, uppercase a is 2. A lowercase, you with me? So that wouldn't be 26. That would be 26 plus 26? 52. So you can make even more passwords by counting a lowercase a and an uppercase a as 2 different things. How cool is this? So this one would be 26 to the 7th times 10. Yay? Just love these problems. And then a lot. It's going to be a big number. How many ways can the top 2 horses finish in a 10-horse race? How many ways can the top 2 horses finish in a 10-horse race? What are y'all thinking? Permutation, combination, blanks.
I want to say that order is important because it says that it's like the top 2 horses.
So I want to know first and second place.
Yeah.
So because I want to know first place and second place, order matters. Okay? So that means it's going to be a permutation problem. So it's a permutation of how many taken how many at a time.
2 out of 10.
The first number is going to be your total, 10, and the second is how many are you choosing? 2. Now, you could have done, if it's a permutation, you can always do blanks. How many choices do you have for first place? 10. And then how many do you have left for second place?
8. Or, hold on. 9.
If Johnny Longlegs gets first place, then you have 9 to pick from for second place. So either one of these is going to give you the answer of 90. So if you're doing a permutation problem, you can always do it as a blank problem. Oh, got one more. 4 members from a 50-person committee are to be selected randomly to serve as chairperson, vice chairperson, secretary, and treasurer. The first person selected is chairperson, the second is vice president, the third is secretary, the fourth is treasurer. How many different leadership structures are possible? What do you think, Travis? Does order matter?
I'm not sure.
If I walk into a room full of 50 people, and I call out Joe's name, and then I call out Sue's name. If I call out Sue's name and then Joe's name, are the results different?
Yes.
If I call Joe first, he's going to be the chairperson. He's going to be the chairperson. If I call Sue, she's going to be the vice chairperson. But if I call it reverse, Sue's going to be the chairperson. And so did the order in which I call them out matter? Yes. So because order matters, what kind of problem is it? A permutation. If the order matters, it's a permutation. The first number is the total number of people that I have in the room. So how many total people do I have in the room? 50. And how many people am I picking from, or picking out of that room? 4. Now, the other way I can do it is I can say, I'm picking 4 people. The first president is the chair. The second person is the vice president. The next person is the secretary. And the next person is the treasurer. How many people do I have to choose from in my hat to pick out a chairperson? 50. And then once I name Joe the chairperson, how many is left for the vice president? And then? I can do it either way. Does not matter to me. It can be that one or it can be that one. Does not matter. So if I go to my calculator, it can be 50, math, NPR 4, or it can be 50 times 49 times 48 times 47. It will give me the same. So that is how many different ways I can choose 4 chair people out of a 50-person room. All right. A family has 8 kids, bless their hearts. If this family has exactly 3 boys, so I don't care out of the 8 children, do the boys come in the beginning, do the boys come in the middle, do the boys come at the end, or do we have girl, boy? I just want 3 boys. So I don't care where the boys come as long as I have 3 boys. How many different birth and gender orders are possible? So I don't care, hint, 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 the order. I just want 3 boys. Don't care the order. So I just said, I don't care the order. Give me 3 boys. So because I don't care the order, what kind of problem is this? A combination. How many kids do I have?
8.
And how many boys am I choosing?
3.
Now, I can't do blanks with a combination. I can only do it as an NCR. So I'm going to choose 8 kids. Ooh. And I want 3 of those kids to be boys. So there are 56 ways that I can have 8 kids where 5 of them are girls and 3 of them are boys. I was one and done. Got me a girl, I'm done. How many different simple random samples of size 7 can be obtained from a population whose size is 100? So I just want groups of 7. Group of 7, group of 7, group of 7, group of 7, group of 7. Do we agree with the equation? James, you agree? This is going to be a combination. Because you are getting a group or a committee or a sample, this is going to be a combination. How many are you choosing from? 100, and how many are we picking? 7. And our answer must be really big.
heard in that one was population.
Yeah, a sample. Population is
Or
gonna be your total, a
sample.
sample. A sample's like a group,
Okay.
yeah. And if we come back to this first page, I had, if you're doing a permutation, they need to be in order, or they need to be in arrangement, or a schedule, or in line. If you're doing a combination, it's gonna be a group, a